Welcome back to my YouTube channel. So let us see question number 19 that was asked in 2020. It says solve graphically the following linear programming problem. So we have a linear programming problem like this. So the question is maximize or minimize this z equal to x plus twice y subject to the constraints. We are given these constraints. So first of all, to start this problem graphically, so we have to plot these inequalities in graphs, two-dimensional graphs. So since there is inequality, first of all let us consider the lines. So first let us consider x plus 2y equal to 100. So let us name it equation number 1. Why I am doing this? Because we know how to draw a line. So it is easier to draw a line than to draw an inequality. So first we are converting these inequalities to some equations. So the next one I will convert to 2x minus y is equal to 0. This will be equation number 2. Next, twice x plus y equal to 200. This will be my equation number 3. Now let us plot these three lines in xy plane. So let me draw the xy plane like this. This is my y-axis, this is my x-axis, x, this is y. This is my origin. So if I want to draw equation number 1, so this will be, if I take x equal to 0, I will get y as 50. So 50. If I take y is equal to 0, I get x is 100. So let me take 50 here. So this will be my 100. So if I draw this line, so this line will be something like this. Okay. Next, what is this? This is nothing but I can say this is y equal to twice x line. So this line I can draw something like this. This will be the line passing through origin. This is my line number 2. Third line I can draw. If I put x is equal to 0, I get y as 200. So this will be 100, 150, 200, 150, 200. And if I take y is equal to 0, I get my x as 100. So this will be nothing but the line joining these 2 points. So it will look something like this. This is my line number 3. Our next task is to find the region which satisfies all these inequalities. Our first equation corresponds to the first inequality, this. So this inequality, that is the first equation. Now I have to find the solution region for this inequality. So the best way to check the solution region for this type of inequality is first you check whether the origin satisfies this inequality or not. That means if I put x equal to 0, y equal to 0, that whether it satisfies. Clearly if I put x equal to 0 and y equal to 0 here in the first inequality, it does not satisfy this inequality. That means my solution region will lie on the other side of the origin. That means this one, the region will lie on this side. Next, from number 2, my inequality is 2x minus y less equal to 0. That means I can say from here, this is nothing but second inequality. I can say this is nothing but y is greater or equal to 2x. So if you look properly, the solution region for this inequality will be this side, the upper side of this line number 2. Again, if I look at the third inequality. So here let us check whether the origin satisfies this or not. Clearly the origin satisfies this inequality, so my solution region will be towards the origin. So this line will be, solution region will be again this side. Now if I find the intersection of this solution region, that means if I see the intersection of this solution region, that means if I want to find the intersection of this solution region, I can say that this portion, this shaded portion, this is my solution region which satisfies all the inequality. So let us name this as, say this one as A, let's name this as B, this C, and this is D. Therefore I can say from figure it is clear that A, B, C, D is the visible region. By feasible region we mean the region which is satisfied by all the inequalities given in the constraints. Now our next task is to find the coordinates of these vertices of these vertices A, B, C, D of this feasible region. Now it is very clear from here that this coordinates of A and coordinates of D are very clear from the figure. These coordinates will be 0, 200, and coordinates of A, this will be nothing but 0, 50, 0, 50. Now we only need to find the coordinates of B and C, and this can be done very easily because B is nothing but the point of intersection of line 1 and 2. So if I solve 1 and 2, I will get my coordinate B. Similarly C is the point of intersection of line 2 and 3. So from, if I solve 2 and 3, I can find the coordinates for point C. Now to find the coordinates of B, let us solve equation number 1 and 2. So from 1 and 2, if I solve, what I will get, x plus 2 into 2x equal to 100. Since y equal to 2x, I have used from equation number 2 in 1. So from here I will get 5 times of x equal to 100, so x equal to 20. Therefore from 2 I can say y equal to 2 times x is equal to 40. Therefore my coordinate of B will be 20, 40. Next, to find the coordinates for C, let us solve equation number 2 and 3. Why? Because our C was the intersection of line 2 and 3. So if I solve this 2 and 3, I will get 2x plus 2x equal to 200. So from here x will be 50, x is equal to 50. Therefore I can say y equal to 2 times x equal to 100. Therefore coordinate of C will be 50, 100. Now let us find the value of our objective function z at these coordinates A, B, C and D. So at A, my coordinate is 0 and 50. Here my z will be 0 and 100 plus I get 100. At B, So it is very clear from here that Z has maximum value 400 at D. So I can say the maximum solution is x equal to 0 and y equal to 200. Again, now since Z has minimum values at A and B, so we can say that Z has multiple minimum solutions, or you can say, in fact, you can say that every point on the line segment, you can say every point on the line segment, this AB line segment, every point on the line segment AB gives minimum solution. So this is my required answer. Thanks for watching.